Hello students of class 9. Today again I will explain one of the most important video of science chapter number 11. Okay, that is the work and energy. Okay, in this video I will explain mainly about the kinetic energy, that is the forms of the mechanical energy. Right, before I start explaining this video, please take out your notebook, pen, pencil to copy down the important topic as well as to draw the important diagram. Let's start today's topic, the kinetic energy. Right? Okay. Look here, kinetic energy. Kinetic energy. This is also form of the mechanical energy. Okay. Then what this kinetic energy means? Now, the energy which is produced by a moving body is called kinetic energy. This kinetic energy means that any moving bodies, they produce some of the energy, right? And this energy is nothing that is known as the kinetic energy. You got my point? That is, I will give the example. In the summer, we use on the fan, right? After we put on the fan, what will happen? The fan blade start moving, right? After moving this fan blade, they produce some of the wind energy. Because of this wind energy, we feel cold, right? That means this wind energy is produced by the moving fan blade, right? That is why the energy which is produced by the moving body is called kinetic energy. That means this wind energy is known as the kinetic energy, and this kinetic energy is produced by the moving of this fan blade. Right? Now, this kinetic energy, it is denoted by capital letter K dot E. Okay? Now, this kinetic energy is denoted by capital letter dot E, and its SI unit is joule. Okay, joule is noted by capital letter J. Right? Now, this is the one thing most important, and now again this kinetic energy is equal to half of mv square. We need to derive this equation, okay? This kinetic energy, the values of the kinetic energy is equal to half into mv square. Okay? Please copy down this first page. Done. Copy it. Done. Okay. Can I remove? Yes. Now expression of kinetic energy. Expression for kinetic energy. Expression for kinetic energy. That means we need to derive the kinetic energy, that is Ke is equal to half mv square. Right? Now consider this object. This is object A. Consider this is the object A. Right. Consider this object A. The mass of this object A is small letter m. Okay. When we apply the sum force, to this object A, when we apply some force to this object A, the object A will be covered some distance. Right, this object A will cover some distance, okay? And due to covering the some distance, the velocity of this object will be changed to v. The velocity of this object will be changed to v. Okay? Any confusion? No. Now, look here. How can we derive? Consider an object A. We consider an object A, right, of mass m. We consider this object A of its mass is m, right, lying at rest. Lying at rest on the surface. That means this object, okay, does not move. That is, this is u. That means u is equal to 0. And rest means this object does not move. Right? Let a force F is applied to the object A. That this force F is applied to this object A, so that what happens if we apply some force to the object A? What will happen? The object will start move, right? The object will start move. That is, the object will covering, so that it covers some distance. How much it covers some distance? S. It covers this much distance. That is, S is the distance which is covered by this object. Okay. S is the some distance to cover this by this object A. Okay. Attains a velocity, attaining a velocity v. Okay. Now look here. This is object A which is lying on the surface, right? At the time, the velocity of this object is equal to 0. That is, it is at rest. Okay. After applying some force F to this object A, then this object will cover some distance some distance S, and for covering some distance S, it attains some velocity. That velocity is known as, that's v. Okay, please copy down this first page. Please copy down. Then finish. Okay. Next, by the definitions of work done. Okay, according to the definitions of work done, what will happen? This work done is equal to force into displacement, right? Work done is equal to force into displacement. Any confusion? Any confusion? Yes? Tell me? No. Right. Now, and look here, work done is equal to or you can say that, or we can write this work done is equal to MA into S. Why this in place of force I am writing MA? Since we all know that this force is equal to MA. According to the second law of motion, we all know that force is equal to mass into acceleration. Right? Any confusion? Any confusion? Tell me. No. Or this work done is equal to we can remove this A, right? We can remove this A. How can we remove this A? How can we remove this A? Okay, before we start that, now, and you come like this and now, or we can write that according to third equation of motion. According to third equation of motion, the square of the final velocity minus of the square of initial velocity is equal to 2 times of AS. Right? This one we will get from the third equation of motion. Right? Now we wanted to find out the values of A, or we can find out 2 of AS is equal to B square minus U square, or A is equal to B square minus U square by 2 of S, 2 times of S. Any confusion? Tell me, any confusion? Okay, now done. Okay, say this is the equation number 2, this will be the equation number 1. Please copy down. According to the definitions of the work done is equal to force into displacement, okay, or work done is equal to MA into S. Why? Because the force is equal to MA. Right? Next, according to the third equation of motion, B square minus U square is equal to 2 times of AS. Right? Now, or 2 times of AS equal to B square minus U square by B square, A is equal to B square minus U square by 2 times of A. Finish? Okay. Putting the value of A in equation number 1. Okay, now this work done is equal to M into B square minus U square by 2S into S. Right? You cancel these two, this S and this S we cancel, right? Or it becomes W is equal to M. It becomes 2M of B square minus U square. B square minus U square. Okay? Or we can write that like this: M B square minus of M of U square by 2. Why? If we divide M in the first in B, it becomes MB square, then U square, MU square. Okay? Now, or W is equal to MB square by 2. Okay? Why? Since u is equal to 0, right? If u is equal to 0, then mu square will become 0, okay? And I'll write in here, that means m of b square minus of m into 0 square by 2. It becomes 0, okay? Since u is equal to 0. Now, or work done is equal to, we bring this one, 2 will be in the front side, it becomes 1 by 2 m of b square. Please copy down this part also. Please copy down this part also. Don't confuse putting the values of a in equation number 1. That means in place of a we wrote b square minus u square by 2s. S and s cancelling, right? Then it becomes mb square minus of mu square divided by 2. Okay? If you confuse, then you write this 2 in this middle part. Right? Now, mb square minus mu square. Right? That means if u is equal to 0, then what will happen? Then this part will become 0. Only mb square minus 2 will be remaining. Okay? When we bring this 2 in the front side, it becomes 1 by 2 mb square. Done? Okay. Finish? Yes. Next. Next, the work done. Next, the work done is equal to the kinetic energy. That means W is equal to K of E. Then K of E is equal to half of mb square. Right? Now where K of E is equal to kinetic energy, m is equal to mass of the object, b is equal to velocity of the object. Okay, please copy down. We all know that work done is equal to for kinetic energy, then we can write this kinetic energy is equal to half mv square, then K is equal to kinetic energy, m is equal to mass of the object, b is equal to velocity of the object. Okay, please copy down this one. This is known as the expressions of the kinetic energy. Right? If you have any doubt, okay, if you go back, okay, to this video and watch from the beginning, okay, 2 or 3 times. If you continuously watch, then you can understand. Okay, now this is for the kinetic energy. Okay, if you have any doubt or any confusions, let me know, but don't forget to watch the video till end. Okay, thank you students, have a nice day. Bye bye.